Hello students. So last class we discussed about the depletion layer formation, and this is the symbolic representation of a diode. Di means two, so it has a two terminal anode and cathode. So this arrow indicates that the current flow direction. Diode is a unidirectional device, or it conducts the electric current only in one direction. So this is a actual representation of a diode. This white color band shows that this terminal is cathode and this terminal is anode. So this contact is known as ohmic contact because it is a semiconducting material. This black color represent it is a metal. So both are meeting at this point. So this contact is ohmic contact because you need to take the terminal from the diode. So that's why we have an ohmic contact. And the first diode was invented by Fleming in the year of 1904, and the first diode was based on the vacuum tube technology or thermionic emission based technology. And this is the thermionic emission based diode, which contains three terminal anode cathode. The third one is a grid or cathode heater point. And these are the semiconductor diodes: BY127, stud type diode, capsule diode, and laser diode, and switching diode, rotary diode, and fast recovery diode. The specialty of fast recovery diode is its turn off time is 0. You can easily turn on and turn off the diode. And the third type is flat type diode. So these are the flat type diodes: your LED and IR LED, and transient voltage suppression diode, step recovery diode, vacuum diode. So these are comes under this category, flat type diode. And one of the important thing is biasing of p-n junction diode. So most of the most of the electronic devices such as diode, transistor, and vacuum tubes, that function is processing AC signal. So it requires a steady state DC supply. The supply may be voltage or current for their correct operation. So by providing a steady state supply or voltage or current at their terminal is known as biasing. So now look at the forward bias condition. We have a p-type material and n-type material. When you join p and n-type material, it forms the depletion layer. So consider this case. So the person, he wants to reach his house. So how can he reach his house? So in between there is a wall. So this wall acts as a depletion layer because these electrons, it will not go into the p-type material, or it will not go into the p-type material because of the presence of depletion region. So if the person wants to reach his house, he must break the wall. So break the wall, he must apply the force to break it. So now he is applying some force. So at last he reached his house. Similarly, if the electron wants to reach the p-type region, the depletion region or the depletion layer has to be broken. So we know very well, last class we discussed about the barrier potential. The barrier potential is 0.7 volt for silicon and 0.3 volt for germanium. So if the electron wants to flow from n side to p side, the depletion layer, it acts as a compound wall. It has to be broken. So we must apply the force. Here the force is not an mechanical force, it is an electrical force. So for silicon we need 0.7 volt is required to break this depletion region, and germanium 0.3 volt is required to break this region. So we will see the function or the width of depletion region as a function of voltage in the next lecture. Thank you.